Good day, geometry students. This week we're finishing up our basic introduction to points, lines, and planes. And next week we're going to start talking about line segments, and then we really start to get into the process of really getting into geometry. One thing I want to say before I get started, a couple of you have reached out to me last week about doing the work on a separate sheet of paper and then submitting it as a picture. I am perfectly fine with that. I think that would actually be easier for most of you. If you do, make sure you take a picture and submit it through Google Classroom. It's in the same way that you would do the assignment, but you would upload it into Google Classroom under the assignment, and then that's fully acceptable. So, geometry with Mr. Chaz. So we're talking about points, lines, and planes, and it would be beneficial for you guys to actually write down these definitions and memorize them. They're going to keep coming up. So, unlike the real-world objects that they model, points, lines, and planes do not have any actual size. In geometry, point, line, and plane are considered undefined terms because they are only explained using examples and descriptions. You are already familiar with the terms point, line, and plane from algebra. So if you remember, you're looking at a graph, a Cartesian plane XY graph. You have a point is anything that's on the line, or this would be considered a point too. If I wanted to say that was point A, that's a point. All right, so a point is anything that's on its exact location, right? So we have point here, and then we have a line. The line is the whole thing. So the line is any line that goes through two or more points. And then the actual graph itself, the grid itself, is considered a plane. So we have our points. Our line is made up of infinite amount of points. Our plane, our lines, and our plane is made up of an infinite amount of lines, is what's going on. It's just crazy. But you're already familiar with that. The phrase exactly one in a statement such as there's exactly one line through any 2 points means that there is one and only one. And that's important because when we get into proofs later on this year, we need to understand the terminology of one and only one, exactly one. So I'm going to go ahead and do a couple examples with you guys. But if you want to pause this video and write this down, feel free. I think it would be very beneficial for you guys to do that. We have a point, it's a location. We have a line, it's made up of points, it has no thickness or width. And then we have a plane. And then we talk about how do we name the plane, how do we name the line. There's multiple ways. To name a point, it's just a capital letter. So example, point A, capital A. To name a line, notice this is PQ, but there's a lowercase m. So we can say that this is line M, denoted by the lowercase letter. We could say it's line PQ. Notice we're not writing anything above it, right? Or we could say PQ, but we put the line above it, right? Or we could say line QP, order doesn't matter, or QP with the line above it. A plane is a flat surface. It's made up of points that extends infinitely in all directions. There is exactly one plane through any 3 points, not on the same line. A capital script letter, or by the letters name, you name it by the capital script letter right here, or by the letters naming 3 points that are not on the same line. So B and D are on a line, but C is not. So BDC would be a plane, right? So we can name it plane K, plane BCD, CDB, DBC, DCB, CBD, BDC. So order does not matter yet again. Collinear points are any points that lie on the same line. So if I have a line here going through points A and B, A and B are collinear, whereas C, being not on the line, that would be non-collinear. So non-collinear points do not lie on the same line. Similarly, coplanar points are points that lie in the same plane. Non-coplanar points do not lie on the same plane. So B, D, and C, they all lie on this plane here. So they are called coplanar. Coplanar, not complanar, coplanar. Now if I had point A over here, A is not on this plane. So that would be non-coplanar. Point A. So like I said, if you want to go ahead and pause the video and write those down, it would probably be beneficial to you. So we're going to use the figure to name each of the following points. Each of the following. A line containing W. So the first thing I'm going to do is I'm going to mark where W is. It's right here. So if you recall, we can name a line by the lowercase letter, or we can name a line by any 2 points on that letter, on that line. So in this case, the lowercase letter would be N. So I can say line N, or I have V, W, X, and Y are all on the same line, but I can say VW, I can say WV. I can say VX, I can say XV. I can say VY, or I can say YV. Notice I can say WX or WY. I can say XW, I can say YW. So these are all the different ways that we can name these points. So all these, WV, VW, VX, XV, and so forth. The line can also be named by saying line N, which we did. Notice that all these have the bar above it. This is difficult to write in Google Docs. So if you just want to type line and then say YV, that's acceptable as well. Alright. Next we have a plane containing point X. So next I'm going to do is I'm going to find point X. Point X is right here. It's smack dab in the middle. And if we recall, a plane needs 3 letters to name the plane. So, and they can't be all on the same line. So I can do X, Y, Z. If you see that little triangle there, X, Y, Z, I can say that's a plane. I can say plane P, which is right there. I can say VZY, that's a plane. I can say WXZ. So there's multiple different ones. But if you notice, T is not included. Because if you're looking, T is actually, this is a solid line going above it. And it's a dotted line going below it. So that's actually saying that it's going through the plane. So if this sticky note was a plane, and if this sticky note was a plane, you can only see it there. And then this letter opener was a line. It's kind of like this. Oops. It's kind of like this. So the plane is going this way, and my line is cutting through it. So this would be T up at the top and R down at the bottom. So that is not on the plane. So point X is not on that plane, except for the fact that it goes through that point. So these are all the different ways that we can name it. Now, if you notice, Let me shrink that, get that out of the way. So I can do X, Y, Z, right? X, Z, Y, V, Z, Y, all these different ones, right? But the letters of each of these names can be reordered to create other acceptable names. So I can rearrange them all. But if you notice, they're all the points that are actually on the plane. So if I were to look at this, the points that are on the plane are V, W, X, Z, and Y. And so we're using any three of these, but Z is always with one of the other two over here because we can't have all three on the same line. So again, when you're drawing these and you're labeling these, it probably would be better to just do it on a separate sheet of paper. So if I gave you an assignment that said, draw plane Q, so that would be this, draw plane Q, I'd label it Q, that has, that contains line AW. So I would put a line on it, A, W. So it's easier to just draw that rather than trying to create it in Google Docs. Last one we're going to look at. How many planes appear in this figure? So 3 points that are non-collinear name a plane. So we have, this one is D, J, H. We have H, E, G. We have D, E, K would be a plane. We have D, J, E would be a plane. We have D, E, F is a plane. And we have F, G, D is a plane. And then we have this whole thing is a plane. So plane X is a plane. So what we have is actually 6 of them that we did. 1, 2, 3, 4, 5, and then the bottom one is 6. So we have 6. We have plane X that we located. We have plane DG. So let me clear it out now. So we have plane X, which would be this whole plane, the base. We have plane, I'll do this in blue, JDH, JDH. We have plane JDE, JDE. Is what we have. Let's go with yellow-ish. EDF. So E, D, and F. That's a plane. So that's in orangey color. We'll go purple. FDG. FDG is right there. And then we have plane HDG. We'll go Scott. HDG. So that was 6 planes. So that's 6 planes. Name 3 points that are collinear. So collinear, the only one that I see is points J, D, and K are all on the same line. So they are what we call collinear. And remember, memorizing these vocab words are important. Name the intersection of plane HDG with plane X. So HDG with plane X, the intersection is going to be HG. That's where they intersect. At what point do LM and EF intersect? So LM, if you look at this, LM is one of those that we just talked about, where it's cutting through the plane. And EF, so EF, if I were to draw my picture going through it, right, because a line does not stop, now I can look at where do they intersect. But it's actually a trick question, because these lines don't actually intersect. Remember, this one's cutting through the plane, and this one's kind of going along the opposite direction, so they do not appear to intersect. So this is your video for this week. You have 2 assignments to do. Again, if you want to do it in Google Docs, do it in Google Docs. If you want to do it on a separate sheet of paper, feel free. Good luck, and as any other time, reach out if you need some help. Thanks, bye. Thanks, guys.